So in this example, the sum of the first n terms of this particular series is negative 132,860. And the question is, how many terms are there? The first thing we have to do is decide what type of series this is. Is it arithmetic or is it geometric? Considering to get from 1 to negative 3, I would have to go down 4. And if I went down 4 again, I would be at negative 7, not positive 9. I assume it's not arithmetic. So it's probably going to be geometric. To find out if it's geometric, I take each term and I divide it by the term before it. This would help me find my common ratio, or R. So negative 3 divided by 1 is simply negative 3. I should verify this with the next two terms, so I'll try it again. 9 divided by negative 3 is also negative 3. So we have confirmed that the series is geometric. Once we've confirmed that the series is geometric, we can now use our sum formula. Recall that the sum formula for a geometric series is Sn equals A, the initial term, times r to the power n minus 1, all divided by r minus 1. Substituting some things in, we know the last term, or the sum of all the terms, is negative 132,860. So Sn equals negative 132,860. We know the first term, T1, is A, and that's 1. And we also know our R value that we've calculated up here. So we substitute these things in. Negative 132,860 is equal to 1. Our R value was negative 3 to the n minus 1. And this is all over negative 3 minus 1. I could simplify the bottom of the right-hand side as negative 4. So what I'll do is I'll multiply both sides by negative 4 to remove the fraction. At this point, what I'm attempting to do is I'm attempting to isolate this term that contains n, this negative 3 to the power n. So multiplying by negative 4 cancels those out and leaves me with negative 4 times 132,860, which is 531,440. Now that's going to be equal to 1 times negative 3 to the exponent n minus 1. Now this set of brackets right here is redundant because when we expand the 1 through, that will just be negative 3n, and that will just be negative 1. So I'm going to add 1 to both sides. That will get me 531,441 is equal to negative 3 to the exponent n. And now this is very similar to our problems that we had to solve in our exponential functions unit. We need to be able to write 531,441 as a power of base negative 3. Well, we know since this is a positive number, n must be even. And if n is even, then it doesn't really matter whether we have a negative here or not. So we can write this as 3 to the power n. Now 3 to the power 12 is 531,441. So I can replace that with 3 to the power 12. Now that I have a common base, I know that if 3 to the power 12 equals 3 to the power n, then n equals 12. And therefore, there are 12 terms. Now, how we got from 531,441 to 3 to the power 12 could be done using logarithms Or it can be done using trial and error, just raising 3 to the power 9, and if it's too small, raise it to the power 11, and if it's still too small, raise it to the power 12. A little bit of trial and error can help you to find this. It's important to know some of the simpler powers, just like it was in our last unit on exponential functions.